Recently, I came across this reel and I got fascinated looking at the shape the liquid surface is forming and thought how can we actually find the equation of this shape? So let's figure it out. So consider we have the cylindrical container in which let's have a look at the drawing. So let's this is the cylindrical container. It is the assume that the top surface looks like this and we have drawn this part, right? So the cross section will be looking like this one, and let's suppose this container is filled with the liquid. Initially the liquid was right above here, the initial liquid level, and let's say this height is let's say it is h naught, and let's have this cylindrical container have axis, this axis of rotation is this one. So let's suppose this cylinder is rotated with the angular velocity omega. So what eventually will happen, as we saw the video, the liquid surface will eventually have a shape like parabola. So let's have this shape. So this is a parabola shape, right? This is the paraboloid shape. So we actually look to find equation of this parabola. This is a regular parabola, symmetric parabola. We want to find the equation of this parabola. So what we will do, we will assume 2 points here. Let's say this is point 1 and this is point 2. So if we put a tangent right over these points, so this is the tangent, and if we actually look at the let's say this point is at a distance r from the center line, and if we draw the fbd of this point, so we want to look at the fbd. So fbd of the arbitrary point, arbitrary point. So suppose this is a point, and it will be mg will be acting downward, the weight force mg, and since this container is rotating, the rotation effect will be propagating through the every point on the surface of parabola. So we will be solving this problem by applying pseudo force. So this point will be experiencing pseudo force in the direction of centrifugal force, this. So we'll be having this as our fc centrifugal, where fc is the centrifugal force, and magnitude of this centrifugal force is m omega square r, where r is the distance of the point, so r. And here, carefully looking at the diagram, let's say this is the angle theta. Let's say the inclination angle is theta. So looking at the geometry, we can write as tan theta will be equal to fc over mg. If we put the values over here, so fc is m omega square r over mg. So if we cancel the mass term, mass and mass got cancelled, so we are left with omega square r by g. Since let's say this is the height over here uh, till the vertex of the parabola, let's say this height is z, and the height till which it rises is let's say h. Taking a small element over the curved surface, we can similarly write tan theta in the other way. So we can write tan theta is equal to dh by dr. So equating these two, we can write. So we what we are doing, we are equating these two tan theta forms. So equating tan theta from both equation, so we can write omega square r by g is equal to dh by dr. Since this is a first order differential equation, we need a initial condition, and that is at the initial condition is at r is equal to 0. So this is the point we are talking about, this point, and specifically this point, and h is equal to z, preferably this. So therefore integrating this equation and we will get, so I take a new page for the convenience. So at last we had this equation, so I write it here: omega square r by g is equal to dh by dr, and we if we integrate this, we will get h is equal to omega square r square by 2g plus c1, where the c1 is constant of integration. Here c1 is constant of integration. I think the page was not visible clearly, so the basic thing I did is I integrated this equation, and here we got c1, where c1 is the integration of constant of integration. So now applying the condition we had, at r is equal to 0, we have h is equal to z. So from this we got c1 is equal to z, and the final equation is h is equal to omega square r square by 2g plus z, and this is the final equation we would tend to require. And if we limit our case to let's say we want to find this equation, and we limit our case to this much portion only, look at the diagram. So if we limit our case study to this much portion only, so we can limit, let's limiting the study area. So we look at this much only. So from here, if we consider this only, we can write z is equal to 0, and accordingly h can be written as y, and r can be written as a function of x. So from this we can actually write equation of parabola. It will be equal to y is equal to omega square by 2g x square. So this is the required more simpler equation of the parabola, and we are at the end of this topic. So thank you for your kind attention.